Hey everybody, apologies. This is a brand new software, so I'm not sure if it's going to be good or not. Also apologize if you hear my kids yelling in the background, but you'll get over it. So here is the start of chapter 9. This is 9.1. This is stuff that you guys already kind of know. This is all about really right triangle trig. Um, so you already know everything about right triangle trig. That's what one of your enrichment opportunities was the other day. It all deals along with SOHCAHTOA. Remember sine, cosine, tangent. So stands for sine of an angle equals the opposite over the hypotenuse. Cosine of an angle equals the opposite, or I'm sorry, the adjacent over the hypotenuse. And then the last one is tangent of theta, and that is going to be opposite over adjacent. So we've got those three. The big thing that we really need to pay attention to is what the actual angles, or what the actual sides are called. So if this is our angle, the one across from that is the opposite. This is always going to be the hypotenuse. The one that's across from the right angle is always the hypotenuse. And then the one that's next to it is always the adjacent. So that should be something that's pretty straightforward. But now we're going to change it up a little bit because there are actually three other trig functions. And the other three trig functions are called secant, cosecant, and cotangent. So what this really is, we have our three. We have sine is opposite over hypotenuse. We have our cosine is equal to adjacent over hypotenuse. And we have our tangent, which is equal to opposite over adjacent. So the other three, cosecant, secant, and cotangent, those are basically just other ways to say sine, cosine, and tangent. Cosecant is abbreviated like this, CSC of theta, and that's very similar to sine because all it is the hypotenuse over the opposite. Secant goes with cosine, so it's SEC of theta equals, and that's hypotenuse over adjacent. And then the last one is cotangent, which is just going to be COT, and that's going to equal adjacent over opposite. So this is just really the same exact thing that we've been doing, except we flipped it. It's no longer opposite over hypotenuse, it's hypotenuse over opposite. So the easiest way to deal with this is to basically just pretend that you're dealing with sine, cosine, and tangent, and then flip it later on. So I'm going to show you how to go through an example with all 6 of the total trig functions, and you'll be able to see how they work. I'm just basically going to do sine, cosine, and tangent first, and then I'm going to deal with the other stuff. In a triangle, if theta is acute, which basically that just means if it's less than 90 degrees, and it's going to give you some information like this, sine of theta is equal to something like 4 over 7. So if it says this, now it wants us to find the other 5 trig functions. So that's what it wants us to do. So now basically what I'm going to do is I'm just going to go through and create a triangle. So my triangle is going to look like this. I'm going to pick one of the angles. It doesn't matter which angle you pick, so I always like to choose that one down there. And then remember, sine is opposite over hypotenuse, so here's my opposite, here's my hypotenuse, so it's just going to be 4 over 7. And then we just have to find that bottom side. And the easiest way to find that bottom side is just by the Pythagorean theorem. So it's going to be, let's use a different color here, or try to. So the other color, or the other thing, is going to be 4 squared plus x squared equals 7 squared, so that's 16 plus x squared equals 49. So then it's going to be x squared equals 33. So that just means that this side is going to be the square root of 33. Now we're going to leave everything exact, at least at this point, which means that we're always going to use radicals. So at this point, if you don't like radicals, you kind of got to get over it because we're going to keep using them. So I'm going to take this away. If you need to, you can rewind that and find it again. So now what we're going to do is we're just going to go through and find the first 3 trig functions that we're already used to. So sine, cosine, and tangent. We already know how to solve those, so that's great. Because what we're really going to do is we're just going to go through and we're going to find all of these trig functions. Sine, opposite over hypotenuse, is going to be 4 over 7. Cosine is adjacent over hypotenuse, so it's going to be the square root of 33 over 7. And tangent is going to be opposite over adjacent, so it's going to be 4 over the square root of 33. Now there's going to be one little problem here, because we're going to have to make sure that there are no radicals in the denominator. Before we do that, I'm going to go through and show you how to find cosecant and all that stuff. So it's just going to be cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. So it looks like this. And now I'm just going to literally flip what sine, cosine, and tangent were. so I'm going to flip those. So sine was 4 over 7, now it's 7 over 4. Secant was cosine was the square root of 33 over 7, now it's 7 over the square root of 33. And then finally tangent was 4 over the square root of 33, now it's going to be the square root of 33 over 4. Okay, so now there's two that we have to change. I don't really have a ton of room on this sheet, and there's no way for me to scroll. So remember, the easiest way to do this is to multiply by the radical. So it's going to be the square root of 33 on both the top and the bottom. So tangent is going to end up being 4 square roots of 33 over 33. And then same kind of thing with secant. Secant is going to end up being 7 square roots of 33 over 33. So that's what that's going to look like. That's how we find all 6 trig functions. Really, there's not much more about that. So with these types of questions, you got to be exact. If it asks you to solve for angles and asks you to solve for things past that, then you don't have to be so exact. I mean, obviously, I'm not collecting things from you at this point, so don't worry about being super exact. Okay. So now the last example that I'm going to do is I'm going to read this out because it's a little bit more, but it's you want to find the side lengths and the angle measures. The book kind of wants you to be exact sometimes, but when you're solving things like this, I don't really care. The big thing that you need to pay attention to is your calculator needs to be in degrees. If your calculator is not in degrees, this will not work. So you have to hit your mode button. Then you have to go down to where it says radian degree, highlight degree, and use that. You have to. If you don't, this will not work. Okay? So this is just something where this is a very simple thing. So if we look at this, we've got a triangle. Looks like this. It tells us that this is a right triangle. One of these is 30 degrees, and maybe I know that the hypotenuse is 8. If it wants me to solve the triangle, it's really easy to solve this triangle because, okay, I know this is a right triangle, and one of them's 30 degrees. That'll make this side 60. And now I just have to use some trig functions. So let's say I want to find this one right here. So that's adjacent and the hypotenuse. So it's going to be the cosine of 30 is equal to adjacent over hypotenuse. I always teach my geometry kids to do this as cross multiplication. If you don't want to, that's fine. If you hit the cosine of 30 on your calculator, it's going to be 0.8660 all over 1 equals x over 8. When you do your whole cross multiplication thing, it turns into 6.93. Now if I want to figure out the last side, I'll just use Pythagorean theorem. So it's really going to be 8 squared equals 6.93 squared plus, we'll call this y squared. So now I'm going to do 64 minus whatever 6.93 squared is. You might hear me type it on my calculator because I didn't do this before. So it's 48 we'll call it 48. So it's going to be 64 minus 48, which is going to be 16. So then I take the square root of that, and this is going to end up being 4. And that's how you solve a triangle. Now that's stuff that you guys should already know how to do, so I'm not super worried about that. But the thing that you guys definitely don't know how to do right now is deal with the cosecant, secant, and cotangent. This should be a pretty quick one. Give it a shot, see what you come up with. If you have any questions, please make sure that you let me know. If you don't have any questions, then that's great. But this chapter is going to get a little bit more challenging as we start to move on. So again, make sure you ask me questions if anything doesn't make sense. Use Remind, use email, use whatever you need. Let me know. Alright, talk to you next time.